Okay, so I got my hands on something pretty fascinating. This is a real computer science test written for 8-year-olds. And looking at it, I had one big question. Could I pass it? Could you pass it? So that's what we're going to do. We're going to go through it together, question by question, and find out.
So what do you think? Are you smarter than a third grader when it comes to code? Hey, no pressure. This is all just for fun. Ready to give it a shot? Let's dive in.
All right, section 1 is all about the absolute basics. Now, in this kind of coding, you give instructions to a little character on the screen. They call it a sprite. We're going to see what it takes to make that sprite not only move around, but actually draw stuff.
And here we go, our very first question pulled straight from the test. You've got 2 different sets of instructions here, 2 scripts, and they both tell the sprite to move. But only one of them is going to leave a line behind. So, which one is it?
Okay, let's look at our options. On the left, the script tells the character to go to the middle of the screen and then move 100 steps. Pretty simple. The script on the right looks almost identical, but it's got one extra command right in the middle, pen down. Take a second. Which one feels right to you?
So, the secret sauce here is understanding this pen block. The best way to think about it is to imagine your little character as holding a pen, but it's hovering just above the paper. It can zip all over the place, but until you give it a command to actually lower the pen onto the paper, well, nothing's going to get drawn, right? That's exactly what pen down does. It's that specific instruction. And that means the script on the right is our winner. See, the computer takes these instructions so literally. It follows them in order. 1, put the pen down on the paper. Then 2, move 100 steps. And the result, a perfect line. You have to tell it every single thing.
And that right there, that's the absolute core of programming, isn't it? The computer doesn't guess. It doesn't assume anything. If you forget a step, no matter how obvious it seems to you, it just won't happen. You've got to be super, super specific. All right, feeling good? Let's keep going.
Okay, we're leveling up. For this next section, we're looking at code that does more than just, move and draw. This is where things get interesting. We're talking about code that can handle information, do a little bit of math, and even talk to the user.
So for this part, we need to know about 2 new types of blocks. First, you have operator blocks. Think of these as your math and logic tools. They're for adding things up or comparing stuff. Then you have sensing blocks. These are kind of like the program's eyes and ears. They let the program ask you a question and then, actually listen for your answer. All right, next question up. So you're not dealing with numbers, you're working with words. You've got the word apple and you've got the word pie, and you want to squish them together to make apple pie. What tool do you reach for? You'd use this little guy right here, the join block. It's technically an operator, and it's basically just digital glue. You pop one word in the first slot, the other word in the second, and bam, it sticks them right together. It's so simple, but you can do so much with it. Okay, let's see how you do with this next one, because it's a little bit of a puzzle. We've got a command here, and the question is, what's the final output going to be? You really got to read the code on this one. So what's so cool here is how the blocks are nested. They're sitting inside each other. The outside block, the big one, says say. That means the character is going to make a speech bubble. But to know what to say, it has to look at the block inside, which says length of the word bag. So what is it actually going to say? The answer is 3. It doesn't say the word bag. No, the computer is being asked to first figure out the length of the word bag. That's B-A-G, 3 letters, and then say that number. It's pretty cool how you can chain these commands together, right? All right, welcome to the final exam. We're moving on from just single commands to reading whole programs. The goal here is to look at a full script from the very top to the very bottom and figure out what the heck it's supposed to do. Let's see how we do. So here's our first full program. Let's try to decode it. Okay, so it starts when you click the character, then it asks you to type a number and it waits. Finally, it looks like it does some math with whatever you typed in and says the result. Let's look a little closer at that. Yeah, breaking it down really helps. Step 1, it asks you for a number. Step 2, it waits and stores whatever you type in a little temporary memory box called answer. Step 3, it calculates. It takes that number from the box and adds 5 to it. And finally, step 4, it says the new number. Okay then, time for the real test. Based on that logic, if you run this program and it asks you for a number and you type in 5, what is the character going to say at the very end? Exactly, it's 10. It takes your answer, 5, it adds 5 more, and the final output is 10. See? It's a perfect little program that takes input, does something with it, and gives you an output.
And here it is, our very last program from the test. This one should look kind of familiar. It's not asking for a number, though. It asks you to type any word, and then it uses that length of block that we saw a little bit earlier.
So here's the final question, worded just like it was on the test. If the word someone types in is orange, what is the final output? Well, we know it's not going to say orange back, right? It's going to count the letters, O-R-A-N-G-E, and the output will be the number 6.
So, how'd you do? Did you pass? You know, whether you got every single one right or a few of them tripped you up, the real goal here isn't a perfect score. It's about starting to see the simple logic behind it all.
You know, the big idea, the thing that makes all of this click, is that this kind of coding is it's like digital Legos. That's really the best way to put it. Each little block has one super simple job. The real skill, the creativity, is all about figuring out how to snap them together in the right order to build something awesome.
And that kind of leaves us with this one big, fascinating thought. We just walked through how these kids are learning to think with this perfect step-by-step logic. They're learning that any problem, no matter how big, can be broken down into tiny, simple, solvable pieces. When that way of thinking becomes just as natural to a whole generation as, building with Legos, what kind of future are they going to be able to build? It's pretty amazing to think about.